Aaron Group Tutorials. Learning made fun.
Hello guys, this is the question that we're supposed to do, the one that you asked for. So I'm just repeating it now so that you try to understand where you didn't understand. So in this question we're given this data. I would say maybe it's a continuation from the one that we did previously, where we were given our vertical angles, our horizontal angles already. So with this one, it's like you had an empty field book. Then you went to the field, you collected your data, and then you filled it in this book, your field book here. Now you're supposed to convert this data that you collected to be the same as that data, the one that you're using in the previous traversing questions, where we already given our vertical angles, our horizontal angles and everything to find the coordinates and the elevation. Now you're supposed to convert this data, the one that you collected from the feet, to be the same as that data, the one that you were given in the previous traversing questions, from exercise 1 up to exercise 4 of the traverse questions. So now you just have this. So from yesterday I said we start with the first table at the top, the 110 horizontal angles. But in our case here, in this question, we are not given the backward bearing or any bearing from T1 to M. So now to find the coordinates of T2, remember, to find the coordinates you need to find the changes dy and dx. So now we have to find our back bearing so that we can be able to find what our forward bearing from T1 to T2. So now since we're given the coordinates of T1 and M, we're going to perform a joint calculation. It's not always like this. If we were already given our bearing, at least maybe our backward bearing, we were not going to do this calculation. We were not going to do the joint calculation. But in this case, it's more complex. You need to find the backward bearing so that you can be able to find your forward bearing by adding it to the horizontal angle, if you remember. So now let me just go to the screen there. So I'm saying in this situation here, we don't have the bearing, so we'll just start by finding our joint first. So remember, we have our station here. We are told that the station, in that question we are told that the station peg number, it's T1. It's a T1. If you look at the table at the top there, the 110 horizontal angles. So it's like you have something like this, just to give you a visualization. You have something like this. Then you have back sighting and foresighting. So you have your M there, you have your T1 here, you have your T2. Just to give you a visualization of this thing, something like this. So now remember, for us to find the coordinates, we need the forward bearing from the point where we are set up to the unknown point, that's in question, which is T2 in this case. So we need this angle, this bearing here. That's what I'm trying to say. We need bearing T1 to T2 so that we can find the change. So now we are not given, hence we are supposed to perform what? The joint calculation. So we find what? We find the backward bearing. We find our backward bearing, which is let me write it as T1 to M. Then we add it to what? To our horizontal angle to give us this bearing T1 to T2. So we're having our horizontal clockwise here. Horizontal. We'll solve for this one using the tables. So we're having your horizontal angle. You just add your backward bearing, then you get that forward bearing T1 to T2 so that you can find your dy and your dx. So the first step in the question, you are supposed to find the join. So you just come here, so you write you're moving from T1 to TM, so you're finding join T1M. So from what you were taught in class, when you have something like this, meaning you're gonna have M minus what, your T1, which will give you what, your change. That's how you're gonna perform this join. So this is how you're gonna answer the question. So this side you're gonna have what, you're gonna have your check. Remember, a join calculation has a check. So now let's write our coordinates. So the coordinates for M, we're given the coordinates for M as -339.993 is to 2900.719 point what? No, this is a mistake. It's not supposed to be 719. This is for T. So 2900.735, 236. So for T1, it's -79376, 829 is to 2900 719,590. So this one, I'm just doing what you know here. This is just a joint calculation. So you just do the subtraction. So it's gonna be that one, the -79339 of M minus -79376. So -79339,993 minus -79376, 829. So what you're getting positive 36,836. Remember, straight decimal places. Then the other side is 2,900,735,236 minus 2,900,719,590. So this side we're getting positive 15,646. So you perform the check on the other side. Remember, I said you just flip this thing. So you're just gonna have the M coming here, then you change, then your T1. Then you just do the opposite of what you did the other side. So you just write the coordinates of, repeat the coordinates of T1. I won't write them because I don't want to make the video long. So you just write the coordinates of M1 is 2 of T1, then write the coordinates here. You put in your changes. The answer that you just found now is 36, 836 is to 15,646. Remember, you'll be having your coordinates there, T1. Then you just do the opposite of what you did. Remember, here we did a minus, here it's gonna be a plus. So you just have your coordinates of T1 plus the change. It's supposed to give you those initial coordinates of M, the -79. What at the top is to 200,900. So that's your check. Like I said, I won't do the check. Then from here, remember, we're interested in the pairing. From here, you just have your small triangle here. Remember, here you have positive and positive. Here you have negative and negative. So here it's what? It's positive and negative. here it's what? It's positive and negative. No, it's negative and positive. Where is this thing? Okay, it's negative and positive. So this is the sign. These are the signs that you have. So now looking at the numbers that you got for our change, the dy and the dx, both y and x are positive. So the y is 36, the x is 15. Remember, this is the y, this is the x, unlike the math y. So coming here, they are both positive, meaning we are in this quadrant, the first quadrant. So your sketch is just here, your line is just here. So your line is just here. Then you have your south, remember here. So measured from the south is your quadrant angle here. Then here obviously you have your what? You have your dy and your dx. So now to find, just apply grade 12 maths, grade 10. So to find the quadrant angle, you just need to use your tan. Remember, you have the opposite in adjacent, that's tan. So your quadrant angle will just be equals to what? Tan inverse of what? Dy over dx, opposite of adjacent. So it's tan inverse of what? Your dy being 36, positive 36, 8, 36 over 15, 646. Then now let's find our quadrant angle. Tan inverse of 36.836 over 15, 646. So you're getting your, remember your angle should have minutes and seconds. So you're getting 66, 59, 12. So that's what we're getting. That's our QA. Let me just rub it. But if your QA falls in the first quadrant, it's the same as your bearing. Remember, here you have what? You have your T, you have your M. So from T to M, that's the angle, 66.59. So that's the angle, that's our bearing, our quadrant angle. But since it's in the first quadrant, it's the same as our bearing. Because moving from, remember, measuring from the north here, from the south. Finding your bearing, you measure from the south. So moving from here to here, we don't need to add anything. We moved from the south to M. So we found our bearing TM. But if our quadrant angle was here, let's say our sketch was here because of the values, maybe the y was positive and the x was negative, we're gonna be in this quadrant. So our quadrant angle, remember, is measured from where? It's our bearing is measured from where? Not our quadrant angle. So our bearing was gonna be which one? So we were gonna have, if it was like this, we were gonna have what? Let me close this thing here. Yeah. So if it was like this, we were gonna have what? We are gonna have our thing, our triangle here, meaning we're gonna have our dy and our dx. So you see our quadrant angle was gonna be this one. So now to find your bearing, we are gonna say, remember this whole angle here, it's 180 from there to the. So to find your bearing, which is your bearing in this case, remember, from if it was, that was our point, it was this, it was gonna be this. So our bearing was gonna be this. So to find that angle, you're gonna have to say the whole 180, which is this one, the whole 180, this whole 180 minus the quadrant angle, then you are left with this one, which is your bearing. But now it's not the case, so our bearing is that one. This quadrant angle is equal to our bearing in this case. So this is the same as our bearing T1. I'm supposed to write T1 here. Our bearing T1M. Yeah. So yeah, that's what's happening. So we have our bearing now. Let's just find our forward bearing. Oh, we can't find our forward bearing because we need our we still need to find out our horizontal angle. So now let's move. So from here you can pause and try to, or you rewind, you go back and check where you missed something. Don't forget your checks. I didn't write the coordinates, but you need to write them. So now let's move. So from here we can just go and deal with the table. Now we have our bearing, so we can just go and deal with our table. So we'll deal with the horizontal angles first. Let me just add another page here. So we're just gonna deal with the horizontal angles. Let me just do this. Okay, we have okay, so from here guys, these are the horizontal angles that we're given. So we're given these horizontal angles. I said the dotted lines just represented the separation between your degrees, minutes, and your seconds. Then after the dotted lines you get solid lines. Those solid lines represent the another, like, different bearings, other bearings. So now 350048 and 27248, they are in the same, some sort of like a column. We can say it's a column. Then 2150058 and 924812, they are also in the same column. So meaning, with regards to backside M, we have 350048. Then we have 2150058. This is how you read this thing. Then what I said the first column there, you can just say it's set 1. Then this one you can just say it's set 2. This one is set 3. This one it's set 4. Then I said the first set, we consider it as what? As clockwise, meaning you're moving from the top going up. Then they just alternate. This one is going down, up, down, just alternate. The first one is clockwise going up, so we said this one is what? Clockwise, anti-clockwise, that one, clockwise, anti. So now for the clockwise, as you can see, the arrow is pointing from down upwards. So we're just gonna say the bottom number minus the top number, we get the value. So here you'll be having your thing here. Let me just write it like this. Here, this. So it will be your bottom number 272 minus 35, like we explained it in class. So you have 272, 48, 00 minus 35, 00, 48. So you're getting 237, 47, 12. Then this one is the arrow points from the top down. So it's 215 minus 92, 215, 00, 58 minus 92, 48, 12. So you are getting 122, 12, and 46. Same thing here from bottom going up. So it's 324, 48, 12 minus 87, 01, 05. So we are getting 237, 47, 7. Then the last one, the arrow is pointing from the top going down. 267, 01, 17 minus 144, 48, 23. So we have 122, 12, 54. So guys, as you can see, here what do we have? We have clockwise. This is another clockwise. Then here we have anti and anti. So this is yellow, yellow. Then the red, it's written that the red is this one and this one. They are clockwise, clockwise. So from here, remember we are interested in finding what? The clockwise, one clockwise angle and one anti-clockwise angle. So from here, we have to find our averages. Then check if we need to make some adjustments now or not. So if there's no adjustment, then we'll be done with this table. We have to move to the second table where we are trying to find our vertical angle. So now if you didn't understand up to this point, you can go back and try to check and then try to make some sense out of this thing. So now I'm saying we're gonna try to find our average angles. Remember, we don't need 4 angles. We need one clockwise, one anti-clockwise. That's the procedure. So from this step here, what are we going to do? We are going to try and find what our averages. So you're gonna have your, let me change this thing here. So you're gonna have your average angles, average horizontal angles. Let me just write this, horizontal angles. So for clockwise, let me just write average horizontal angles. So for clockwise, you're gonna have that. Remember, clockwise is this 237. It's written there, clockwise and clockwise. So if you are wrong, you'll see the clockwise angle, if you check, they're almost close to each other. The anti-clockwise, the magnitude, in terms of the magnitude, they're almost close to each other. So you have 237, 47, 12 plus 237, 47, 07, divide by 2. So now let's see what are we getting. 237, 47, 12, 237, 47, 12 plus 237, 47, 07 divided by 2. So we are getting 237, 47 and 9.5. Remember, I said not decimals, so 9.5 is the same thing as 10. So 10. So that's our reduced horizontal angle, our reduced horizontal clockwise angle. So this is our reduced horizontal. Let me just write clockwise here so that you can see. Oh, but it's not safe to conclude that it's already reduced if you have not checked. So let me just remove it for now, because we have not yet checked. Then we can conclude after we have checked. So now let's find our average horizontal angle, but this one is the anti-clockwise. So we just add the anti-clockwise angles. It's this 122 and this 122. So 122, 1246 plus 122, 1254 divided by 2. So from here we have 122, 1250. So that's our anti-clockwise angle. Now let's go and check. So clockwise, anti-clockwise, then you have your check. Remember, when you're adding them, they're supposed to give you 360. Horizontal angles are supposed to give you 360. So now our clockwise, we said, is 237. So it's 237. Okay, 47, 10, 47, 10. That side it's 122, 12, 50. So now let's try and add them. I was not supposed to write that 360 already, but let's try and see if they are giving us 360. So 122 plus 237, 47, 10. So now they are giving us 360. So now we can conclude these are our, we have our reduced what? Horizontal angles. So we have our reduced horizontal angles. Yeah, I'm just chopping the words here. So you have your reduced horizontal angles. Now you are sorted. So this 237 here, this is the angle that we're gonna add where? To this bearing here, the backward bearing, to find the forward bearing. Remember, to find the forward bearing, we said forward bearing is equals to backward bearing plus horizontal clockwise angle. So that's how we're gonna find our bearing there, from T1 to T2. So now let's go and continue. So we have these angles. Now we go to the second table. So now we are done with the first table, the one with the horizontal angles. We go to our vertical angles. So with the vertical angles, I'll pause the video and so that I can write the values here. Or even if I don't write them, you guys can just look at the question while I'm doing it here. So with the vertical angles, we have, under each alphabet there, we have two angles if you check. So for M, we have 90, 35, we have 90 degrees, 35 seconds, 35 minutes, 7 seconds. Then also have 269, 24, and 32 for M alone. Then for T2, we have 89 and 270. So yeah. So now let's go. Now we are dealing with what? The vertical angles. So now dealing with the vertical angles. So it's those vertical angles there. We're gonna deal with M separate. Then we come and deal with what? With the T. So under M, you're gonna have what? Oh, before you deal with the vertical angles, I advise you throw this Cartesian plane. So we have this Cartesian plane here. That's your Cartesian plane. You have your 0, you have your 90, you have your 180, you have your 270. So this is what I've been using. It works. So yeah, obvious 360. So what I figured out is that if you take the angles between these numbers here, this side, so this side, let me just use different colors here. Let's use blue this side. Let's say we have this. I'm trying to use blue here. Okay, let's see. So this side we have this. So any angle that falls between 0, this side between 0, if you check here, we are from 0 up until we're up to 179. Then the 180 is that y, the x-axis. So from 0 to 179, I'll just say. Then this side, remember we are continuing. After this line here, this solid vertical line, we have 181. So here from 181 to 360. So this thing works, guys. This rule works. So we have two reduction formulas. They act like reduction formulas. I just like calling them reduction formulas. So these two reduction formulas, this side it's 90 minus theta, with theta being your angle. This side it's theta minus 270. That's what you're gonna apply. These two formulas, these are important. So if your angle falls between 0 and 179, you use this 90 minus theta. If your angle falls between 181 and 360, use this angle. Use this, it can be 180. Let me not say 181, because it can be 180 and some maybe seconds nyana. So let's say you had 180, 59, 40. Let me say you had this. I want to say something here. Okay, let me not specify. Let me not say 180. Let's just say 180. Let's just 180, not 181, because it can be 180 and some seconds, which is 180,99 something. So let's say here 180, 179 here. So it's 180 to 360. Let's say 180 but excluded, ne? We're excluding the 180. Okay, let me write it in terms of maths. Let me say 180 less than theta 360. So we're including this. Let's write it like that, because it can be 180 in some seconds. You see, that number is less than 180. It's greater than 180. So if I say 181, you will assume that if it's less than 180, it's this side, and it's not the case. So that's why I'm saying 180 is excluded. So theta here is greater than 180. You see. So this side, you can just say from 0 theta to 180. Now, so just write it. Let's write it this way. So I hope you understand, guys. Now I hope you understand. So if your angle is between this, so it's between 0 and 180, but they're both excluded. Yeah, it's between 180 and 360. I'm just including the 360 there. You see. So meaning your theta can be 180 and some seconds, meaning it's 180,99. It's greater than. It's this side, not this side. So now let's continue. Let's go to our VA. So for M, we have, I said you first draw this thing, this table, this Cartesian plane. So for M, you go and write, né? So you just write M1. Since you have two angles, you're gonna say the first angle is M1. So our M1 from that table that we're given there, it's 90, 35, and 07. So now let's come and look at our thing here, our Cartesian plane. Where do we find that 90? Obviously it's on this side between 0 and 179. So it's between 0 and 179. So meaning we're going to use which formula? The 90 minus theta. You see? Therefore, we're going to have 90 minus theta, which is 90 minus what? 90, 35, 07, which gives us what? So now let's calculate and see what we're getting. So it's 90 minus 90, 35, 07. So you're getting negative 0, 0, 35, 7. So this is what I'm getting. Then we come and go to M2, ne? M2 from that table under vertical angles. We have 2, 6, 9, 24, 32. Yeah, 29, 24, 32. So now let's come and check and look at our Cartesian plane. Where do we find that 269? It's on this side of 270. So we're gonna use theta minus 270. Therefore, our angle is gonna be theta minus 270. So we're gonna have theta being this angle, so 269, 24, 32 minus that 270 there, which gives us what? It's supposed to give us an angle close to that one. So 269, 24, 32 minus 270, 0, 0, 0, 0. So you're getting negative 0, 0, 35, 28. So those are the angles that you are getting. Then we have to find the average angle. So that average angle that we're going to find, that will be our reduced vertical angle for M. Then we still have to do the same thing for T2. So now we find our average angle. So finding an average, if you have two numbers, to find the average, you just add those numbers and divide by 2. So you have your, you can just decide to add them without the signs. Then the answer that you get, you plug in the sign, or you just add them with the sign. It's up to you. So you have negative 0, 0, 35, 0, 7 plus, that's why I wanted to avoid the signs, but let's just put them so to avoid confusion, so that you guys don't get confused. 35, 28, divide by 2. So we have this answer plus negative 0, 0, 35, 28 over 2. So we're getting, I shouldn't see this thing. So we have negative 0, 0, 35, 0, 7 plus negative 0, 0, 35, 28 over 2. Okay, so we have negative 0, 0, 35, 18. So I hope I pressed this thing correctly. So 0, 0. So that's the number that we are getting. This is our reduced vertical angle for what? For M. So now guys, we're gonna repeat the same thing for T2. We're also given two angles under T2. So T2, we're gonna have T21. So our T21 is equals to 89, 0900. So looking at our Cartesian plane here, that 89 falls where? It's on this side of the quadrant. Where does 90 minus theta? Because it's between that 0 and 179. So you come here. Therefore, this is gonna be what? 90 minus theta. So 90 minus 89 is 0900, which gives us how much? So 90 minus 89, 00, 09, 00. So we're getting 0, 0, 51, 0, 0. That's what we're getting. Now then we have T2, the second angle there, which is 270, 50, and how much is this? And 48. So going to a Cartesian plane, where does this angle fall? It's this side, between the 180 and 360 there. So now you you have to use what? Theta minus 270. Remember, we only have two formulas for reduction there. So theta minus 270, it's theta minus 270. Theta is 270, excuse me, 270. 270 and 50. So it's 270, 50, 48 minus 270. So this gives you how much we are getting. So 270, 50, 48 minus 270, 270, 50, 48 minus 270. So we are getting 0, 0, 50, 48. So now same thing that we did for M, we find our average. Remember here we found what our average. So this is our average T2. So remember here this was what our average average M here. So here this was our average, this is our average T2, the whole T2 combined, T22 and T21. So you have your 0, 0, 51 plus 0, 0, 50, 48 divided by what? By 2. Okay, we have 0, 0, 51, 0, 0 plus 0, 0, 50, 48 over 2. So this gives us 0, 0, 50, 54, and this is our what? Our reduced vertical angle for what? For T2. This is also important. Let me just highlight this. So this is important, we're gonna need it at some point. And also this one. So now you are done with those two tables. So the aim of those tables was for you to find the horizontal angles and also your vertical angles. So now from here you can just go and apply the normal steps that you know, the ones we were using on our previous traversing questions, the theory one there. So now let's move. So from here we need what? We need our dy dx, we need our hd and our vd. Then we get our coordinates, then we find our elevation. So now let's move. So we can find now, what do we have now? We have our vertical angles. Remember, you can't find your dy and your dx without having what? Your hd. So we are forced to find our hd first before we can find our dy dx. You see. So now let's go. So this is what you're gonna have. So now we are finding what? We are finding our VDs and VD and HD. So now it's VD, this thing. So you are finding your VD, your vertical difference, the vertical distance, and your horizontal distance. If you check, we don't have any checks here. We only had what check? This check for the horizontal angles and also for our joint calculation. We had our checks there. I didn't do this check. There's supposed to be a check here. Remember, there's a check for what? For this thing, for a joint calculation. So you can also do your check this side for the joint calculation. So let's move. Now what do we need? Okay, so you need to do your check here. Remember, write your check here. Didn't write it. Then also have that check, have this check for the joint calculation. Then you have this check. So far we have only 3 checks. So now yeah, let's move now. So now we have to find out our VD and our HD. So with this one of the practical, how it's done, you find your VD and HD for your, remember you have 2 vertical angles. So you're gonna find what? Your VD and your HD for your M, and also a VD and HD for your T2. But remember our point of interest, which is T2. We're looking for the coordinates of T2. So the one that you're looking for, you just put it on the right. like we always do, the one that you are finding, remember, always put it on the right, on the left of the page. Then we always have our check on the right hand side. So this M is acting as some sort of check, but it's not a check as such. So what you're looking for is on the left, your check is on the right. So for T2, remember I showed you guys that when you're finding our HD, so you have your VD and your HD. Your VD, I said, is equals to what? I said it's equals to your SD, your sloping distance. Sine what? Sine your vertical angle. So the same thing applies the side. VD is equals to your SD sine your vertical angle. Then your HD, we said it's equals to your SD cos your vertical angle. So this side also, HD is equals to your SD cos your vertical angle. Remember guys, you only do this for the practical calculation. For that normal one where you are already given your data, the check is different. You're gonna use your Pythagoras this side to prove that your SD is correct, your VD and HD are correct. You're gonna use your Pythagoras as your check, but here in this case you use this one. So our SD, you go to your what? You go to your table there. If you look at the table, let me just try and go to that table. So now let's go to our table there. Let's just continue. So looking at our table, there's where under vertical angles we have vertical angle, we have BS to peg, then we have BS being backside to peg, then we have vertical angles, then we have distance, then we have P bob, then we have rail. So your distance, your sloping distance, it's the one that's written under distance, under the distance column. So for T2, under the distance column, if you check, you have 158,868. So you just come and plug that here, 158,868 under T2. Then sine, obviously you're gonna also have 158,868. Then you have your cos, then you have your okay here. So for M, under distance, we have 98. That's our SD. We have 98,568. Then sine our vertical angle. Same thing here, 98,568 cos our vertical angle. So now let's go back and see. We did find our vertical angles. For T2, our vertical angle was this one, our reduced vertical angle. That's our vertical angle for T2. It was 0, 0, 50, 54. So you just come and plug it here. 0, 0, 50, 54. Same thing here, 0, 0, 50, 54. For M, we had a different vertical angle. So for M, it's this one. It was negative 0, 0, 35, 18. Negative 0, 0, 35, 18. Negative 0, 0, 35, 18. So you just punch these things, you get your numbers here. So I won't press that side of M, you just press it. I'm trying to save time. So that side of M, you're gonna punch your calculator and just plug in the value that you're getting. Write it down here and also here. Well, let me just write it down. Okay, I won't write it down, guys. You just plug it. Alright, let's write it. Because you're gonna need the VD when you're doing a back check. So it's 98,568 sine negative 0, 0, 35, 18. So you have negative 1, 0, 1 2. Then when you're plugging cos, we have what? We have 98 comma 562. So now let's come to this side of interest. So 158 comma 868 sine 0 0 50 54. So here I'm getting 2 comma 352. Yeah, that's what I'm getting. So then for the HD, we just change input course here. For HD it's 158 comma 851. Now we can find our dy and our dx because we have our HD. So now we are finding what? Dy dx. And yeah. So now let's go and find our dy dx. So our dy dx, excuse me. So finding our dy dx, remember we still use the same thing that of saying our dy and our dx, they need what? The forward bearing. So now let's find the forward bearing first before we can go and find what? The dy dx, because we need our forward bearing. So remember we had what? We had our backward bearing, which was our T1M being equals to what? 66. Let's go and confirm it. It was 66. Where's that backward bearing here? The one that we found using our joint. It was 66, 59, 12. 66, 59, 12. 66, 59, 12. Remember this thing, you can just put a check here. 66, 59, 12. Then you're gonna have what? Your horizontal clockwise, and you wanna add it. So horizontal clockwise, we found it here. It was 237, 47, 10. This one. So 237, 47, 10. 237, 47, 10. Then this is gonna give us our forward bearing, which is T1 to T2. So when you press this, you have 66, 59, 12 plus 237, 47, 10. So you're getting 304, 46, 22. And after that you can just do your check. Remember it's just gonna be the opposite. So you have M to T1, then you have your horizontal anti-clockwise, which is minus, then you have your T2 to T1. We just have the opposite here at the side. So your anti-clockwise, you can minus it from 360. You can just come and take this one. It's the same one. Anti-clockwise, we found what? 122, 1250. There was 122, 1250. Then this one, remember the difference between the forward bearing and the backward is 180. So our backward, that's 69, 59, 12, which is less than 180. So I said if your angle that you're having, either it's backward or forward, it's less than 180. To find its partner, whether you're looking for the forward or the backward, if it's less than 180, you will add 180 to it to get what? The partner. If it's less than 180, you add 180. If it's more than 180, you subtract 180. So this 66 is less than 180. So now to get its partner, which is the opposite of T1 to M, we want to add what? 180, because it's less than 180. So here you just have 246, 59, 12. Then you just subtract them. Minus 122. Just do the opposite of what you did that side. 122, 1250. So you're getting 124, 46, 20, 22. And when you subtract them, you're supposed to get a difference of 180. Remember, because it's the forward bearing and the backward bearing. So you're getting 180. So now, since you have your forward bearing, the one that you're looking for, you can find what your dy and your dx. So now, finding our dy and our dx, remember, we check using our backward bearing. It's gonna give us the same thing but opposite sign. Same thing that we're doing that side for the theory calculation. So you just come here. Remember, we said what? Our dy is equals to what? Our hd and what? So it's equals to our hd sine your forward bearing. Your forward bearing in this case being T1 to T2. The dx is equals to hd cos your forward bearing, which is T1 to T2. Then that side of the check, it's the same thing, just now you're using the backward bearing. So it's still hd sine, but the backward bearing, which is T2 to T1. Then you're gonna get your answer here, your answer there. Then your dx, same thing, but backward bearing for the checking side, T2. So now let's plug in our numbers. So you just plug in your numbers. I won't put them. So you have that 304. You just put it here for your forward bearing. But let's just write it, because some of you might end up not writing them in the test. So we said our dy is equals to, so hd, our hd, we found it. We found our hd as what? Remember, we're interested in the hd of what? Of T2, because we're interested in T2, not the M1. So these ones were just there for back check calculation. So our hd is 158,851. So 158,851 sine your bearing T1 to T2, which was 304, 46, 22. Even here 158.851 cos 304, 46, 22. This side is the same, 158,851 sine, but our bearing has changed. It's that 124, 46 there at the top. Just write the whole bearing. HD. So we have 158,851 sine. Not sine, man. It's supposed to be cos here. Cos. So cos your 124, 46, 22, that bearing at the top. So now when you press these things, we're getting for dy, we're getting 158,851 sine 304, 46, 22. So here for dy, so I'm getting negative 130.483, 158,851 cos 304 or sine 304, 46, 22. Okay, 130,483. Then for dx, we're getting what? Cos, we're getting 90. comma 5 9 6. Then that side you're gonna get the same numbers but opposite sign. So you're gonna get the same number for dx, but it's gonna be negative 90 comma 596. So here when you're pressing, you're gonna get the same number but in opposite sign. You're gonna get negative 158 comma 851. So that's what you're having. So now you have your dy, your changes. You can find your coordinates. Remember, we're moving from where? If we come back here, we are moving from the known, from t1 to t2. So we're gonna move from t1 to t2. So we need the coordinates of t1. Then we add our changes. You wanna know how much did we change with in the x direction and the y from t1 to t2. So now you're gonna have what? You're finding your coordinates. You're gonna have t1 and your changes. They're supposed to give you what? Your t2. You also have a check. So now let's see. So for t1, you just go and look for your coordinates. Like you're given the coordinates there. It was 70 something. So the coordinates was negative 7 9 3 7 6 comma 8 2 9. Let me just wrap this one. Then 2 2 9 0 0 719.590. Then you have our checks that side. Then you have your changes, your dx, your dy being what? 150. Oh, dy being negative 138. Oh, ish. You're supposed to get. Let me wrap this there. You're supposed to get. You got negative 130. When I add positive for dy, positive 130.43. So yeah, should avoid these mistakes, guys. So yeah, let's see the y. The x, yeah, it's fine. So now for dy we got negative 130.483. For x we got 90.596. So from here, guys, you just do the opposite of what you were doing for a joint calculation. When you're finding coordinates, is this 7 9 7 1 8, it's 2, this one. You do the opposite of what you were doing for joins. When you're finding a join, you're finding a change, so you subtract. Here you're gonna do the opposite, you add. So you're gonna have negative 79376.829 plus negative 130.483. So you're getting negative 79507.312. Then you come that side, you have 2,900 719.590 plus 90.596. So we're getting 2900.810.186. So those are your coordinates for what? For t. For t2. So now you have your coordinates. Now we are short of what? Your elevation. We are moving from t1. Oh, the check. You're supposed to do a check. Do a check, guys. Do a check now. So now, since you have your, what do you have? Your coordinates. You can perform your check. And for this one, for the check, you do what you know, you just flip it. And you flip it, you find the coordinates. So if you flip it, remember, you're gonna have your dy here, somewhere here. Then you have your t1 here. Then you have your t2 there. So you just write your coordinates and your changes. They're supposed to give you your t2, your t1. That's your check. So now the last part where you're supposed to find the elevation. So you're moving from where? From station T1. So you're given the elevation there. So you're gonna have your elevation at T1. This side you also have what? Your elevation at T1 equals to. So it's like a back check. So elevation at T1, it was positive 1668,862. 1668,862. Then you're gonna have your IH or TH. It doesn't matter the order as long as you have them. You have all of them here written. Then these are gonna give you elevation where at T2. This side, these are gonna give you the elevation at M. You're gonna have your AH, TH, your VD. So our VDs, we take them as they are. They match with the signs. The sign of VD goes with the sign of your VA. So our VA for T1, let's check our VA. It was positive. It was 0050, or a positive number. So you're gonna have a positive VD here. For this one, our VD was negative. Where's our VD here? It was negative 0035 for this one. So you're gonna have a negative here. So the values for VD, we found 2, so for VD there we found 2,352 for the T2. So you had 2,352. That side you had what? You had negative 1,012. Negative 1,012. So our target height, it's there on the table in our instrument height. So our instrument height is 1,430. If you look at the top table, the one that's in horizontal angles, at the top right corner there, it's written one instrument height 1,430. So you have 1,430, 1,430. And you are told that you're on university grounds. So if you go back and read, there's rules there in your book. It's written if you're on surface there, this one is positive. The instrument height is positive. You see? So for surface, we are told that the instrument height is negative. You see? So it's negative. Oh, our instrument height, I said it's our P-bob. When you go to a table that's written vertical angles, that's where you find your vertical heights. Remember our instrument height, I said it's where top right corner on the first table, it's written instrument height. For your vertical height, it's under the table written vertical angles. The P-bob, that's your target height. For T2, it's written 1,368. Don't make a mistake and take that 1,367. For T2, we have 1,368. Then for M, we have 1,367. So you just press this thing. So for TH, you make the opposite. Just gonna put the opposite sign of the TH, opposite to that side. So the important sign was that IH, it's positive on surface. VD, same sign as your VA. Then your TH, on surface, negative. That side, you keep your IH and your VD, your IH the same. Your VD, remember, it follows the sign of the VA. So our VA was negative for T1. For T2, for M, man, it was negative. So now you just change the sign of the TH. So you just press this thing, you have 1668, 862 plus 1,430 minus 1,368 plus 2,352. So this is giving us 1671,276. So that side we are getting, okay, let's see that side of M. So it's plus 1,367 and negative 1,0012. We have 16 what here? 70,647. So your final answer for T2, you have what? You have your elevation. Let me put this thing. So for T2, final answer, you have your, okay, the coordinates, you have your Y, you have your X, you have your Z, which is your elevation. So your final answer is -79, this one, 507,312. Then for X, what do we have? We have 2,900,810.186. Then our Z, which is our elevation, we have 1671,276. Then you're done. So when they are marking, they'll start checking your final